This evening, the paleontology of print is not our only theme. Knots too will occupy us. Dear colleagues, ladies and gentlemen, a warm welcome to everybody. Knots, this is first of all because our distinguished speaker, Susan Dackerman, has written, among other things, a book on Dürer's knots, that remarkable series of woodcuts with their intricate knot ornaments. Dürer's knots evoke Leonardo da Vinci and were collected by the Sultan in Istanbul and thus connect very different places and people. One might say that knots lead almost automatically to networks. And this brings me to a second reason why the paleontology is not the only topic. The conference, Resources of Printmaking as Resource, Shifting Perspectives on Early Modern Print, within whose framework this evening lecture takes place, this conference itself functions as such a knot. The event is organized by Ulrike Kuiper of the Staatliche Graphische Sammlung in Munich and Hui Luan Tran of the University of Mainz. And my sincere thanks go to all three, Susan Dackerman, Ulrike Kuiper, who unfortunately is ill, and Luan Tran, for one of the central functions of the Zentralinstitut for Art History is precisely to provide a platform for such gatherings, to serve as a hub for art historical research, even when, as in this case, the expertise and the individuals involved are not based here at the ZI. After all, the Altmühltal, which will serve as the protagonist of the lecture, lies just 100 kilometers north of Munich, so the ZI is thematically as well very much the right place for your lecture. Many thanks once again. Enjoy the lecture, and I hand over to Hui Luan Tran.
Ladies and gentlemen, colleagues and guests joining us online, I warmly welcome you to today's keynote lecture, which is part, as already said, of the workshop Resources of Printmaking as Resource. And please allow me a few words on the workshop. Research on printmaking has gained significant momentum in recent decades. Rather than viewing prints merely as vehicles for images, scholars have increasingly emphasized the material and aesthetic qualities of prints, as well as the epistemic agency of printmaking. Yet despite this growing interest, the medium continues to occupy a marginal position in art historical theory. The persistent perception of prints as derivative or reproductive has contributed to this marginalization. It has overshadowed the complex material conditions, collaborative production processes, and economic entanglements that shaped printmaking practices. Even recent theoretical approaches often reproduce traditional hierarchies that privilege painting, sculpture, and drawing. And this imbalance has its roots in early modern art theory and points to a clear research gap: the need for methodologies that account for the specific material, ecological, and processual dimensions of early modern printmaking. The workshop organized by Ulrike Kuiper and myself therefore proposes a methodological revision. Our aim is to approach early modern printmaking on its own terms. We address the affordance of the medium with three main arguments. First, within the context of printmaking, a teleological model of the artwork proves insufficient. Prints must instead be considered within their own paradigms of production and reception. Our workshop therefore proposes a process-orientated concept of the artwork, one that challenges established notions of authorship, originality, and the idea of the masterpiece. Each stage of image production becomes relevant. From the selection and preparation of the matrix, through the procedures of printmaking, to the multiple phases of reproduction and alteration of the printed image. Second, the material foundations of printmaking are of particular importance. Printmaking emerges from a complex and collaborative process involving copper, wood, paper racks, paper, wax, ink, solvents, and other chemical substances. These materials not only determine technical possibilities, they also shape aesthetic decisions. Processed in a proto-industrial context, these materials constituted finite resources. Their procurement through forestry, mining, and paper mining often carried social and ecological consequences. And this brings me to the third argument. We argue that ecologically informed approaches are essential for analyzing printmaking practices. From this viewpoint, printmaking appears as an art from deeply entangled with ecological and economic systems, while at the same time constituting a measure of artistic production in its own right. It is now my great pleasure to welcome our keynote speaker, Susan Dackerman, one of the leading international scholars in the field of print history. Currently a lecturer at the University of California, Los Angeles, Susan has held several major curatorial positions, including at the Baltimore Museum of Art, the Harvard Art Museum, and the Cantor Center for Visual Arts at Stanford. From 2015 to 2017, she was a Getty Scholar at the Getty Research Institute in Los Angeles. And in the spring semester of 2025, she was visiting professor at Princeton University. Susan's research focuses on the visual culture of the 15th and 16th centuries, and in particular on the ways printed images generate, transmit, and circulate knowledge. Her work combines art historical analysis with a strong interest in materiality, production processes, and the cultural networks in which prints were created. Among her publications that have significantly shaped our understanding of early modern printmaking, I would like to highlight two particularly influential exhibition projects and their accompanying catalogs. With the exhibition and book Painted Prints, the revelation of color in Northern Renaissance and Baroque engravings, etchings, and woodcuts from 2002, Susan challenged a long-standing assumption, namely that early modern prints were fundamentally conceived as black and white images. She demonstrated that the coloring of prints in the 16th and 17th centuries was often not a later addition, but rather an integral part of their original design and visual effect. Her seminal catalog, Prints and the Pursuit of Knowledge in Early Modern Europe from 2011, explored the close collaboration between artists, natural philosophers, and artisans in the early modern period. The project showed how central printmaking was to the production and dissemination of knowledge. Among her most recent publications, which was already mentioned today, is the book Dürer Knots, Early European Print and the Islamic East, published with Princeton University Press in 2024. In this study, she places the work of Albrecht Dürer within a broader global context and explores the connections between European print culture and the Islamic world in the early age of print. Susan is currently working on an ecological history of print matrices, woodblocks, copper plates, and lithographic limestones. This project asks how the choice and use of these materials were shaped by environmental conditions and how the use of wood, metal, and stone was informed by contemporary conceptions of the natural world. Susan has not only kindly agreed to deliver the key lecture for our workshop, but will also present a paper on ecologies of Dürer's wood blocks on Friday, yes. So we're extremely grateful for her generosity in allowing us to draw on her expertise twice during this workshop. I would also like to take this opportunity to thank the other contributors, namely Livia Cardenas, Ruth Ezra, Emily Friedman, Sung-Hoon Lee, Ariela Minden, Marius Rimmele, and Daniela Wagner. Their commitment to submitting drafts of their papers in advance and engaging closely with each other's work is by no means something we take for granted. With the curatorial talks that we also have by Soo-Yeon Choi, Min Young Kim, Elizabeth Wyckoff, and Sibbe Wartener, we try to build a bridge to the museum practice as well. Our thanks also goes to the team of the Zentralinstitut für Kunstgeschichte and the Staatliche Graphische Sammlung München for their advice and support. We are, last not least, deeply grateful to the Karin and Uwe Hollweg Stiftung and the Fritz Thyssen Stiftung, whose generous funding made this workshop possible. But for now, we are very much looking forward to this evening lecture by Susan Dackerman entitled The Paleontology of Print, Lithographic Limestone, and the Nature of Reproducibility. Please join me in welcoming Susan Dackerman.
Thank you, Luann, and I'd like to thank Ulrika for inviting me here. It is a great pleasure to participate in this workshop over the next few days. I look forward to the conversations that will emerge among the participants. It's also a great pleasure to talk about the paleontology of print, this stone that is local here in Munich. I have been thinking it through in Los Angeles, which is, of course, a very different place. So I look forward to thinking it through with all of you here this evening. From the development of woodblock and copperplate printing in Europe in the 14th and 15th centuries, through the invention of lithography in the 18th century, making prints has left a trail of fossils, discarded print matrices inscribed with a pictorial history. In the best case scenarios, the matrices are preserved for study, such as at the Istituto Centrale per Grafica in Rome and the Bavarian Surveyor's Office here in Munich with its archive of maps etched in stone. But more commonly, woodblocks, copper plates, and lithographic stones, regarded as artifacts of the production process, were reused, repurposed, or destroyed. Currently, printmaking as a physical medium, one that is manually materialized via such tangible matrices, is being replaced by digital media and consequently also disappearing. This imminent extinction of traditional printmaking technologies can be reimagined through an investigation of its material matrices, especially its lithographic stones, and their relationship to the conception and study of fossils in early modern Europe. Reframing the history of print and the invention of lithography through the lens of paleontology enables not only a reconsideration of the ongoing loss of print as a physical mode of knowledge production, but also a reconceptualization of the relationship between printing, nature, and natural processes. Ultimately, such a reframing also engenders a reassessment of lithographic limestones themselves. By the time the Munich playwright Alois Sennefelder discovered the reproductive possibilities of Bavarian limestone for printing lithographs, the stone's generative potential had been exploited by artists and artisans for centuries. That time frame, however, is negligible when compared to the millions of years that the Earth itself had been reproducing figurative images as fossils in the same stone. The determination by the French naturalist Georges Cuvier that those fossilized plants and animals represented petrified organisms, some of which were no longer extant, chronologically and geographically coincides with Sennefelder's printing innovation. Prior to Cuvier's breakthrough, the extinction of species was not universally accepted. Thus, the limestone's image-making capabilities were misunderstood. Examining in tandem the synchronic concurrence of the recognition of the concept of extinction and the development of lithography, two seemingly distinct occurrences yields new perspectives on these established historic narratives. Both discoveries emerged in 1796 from the limestone quarry in southern Germany and radically transformed Western beliefs and their communication. Neither, though, was a flash of kismet. but the culmination of centuries of engagement with the limestone found in the Altmühltal Valley around Solnhofen, Eichstätt, and Kehlheim, as well as centuries of appreciation of the sedimentary rock's generative potential. The confluence of these dual historic events driven by Bavarian limestone enables the articulation of an intertwined history of paleontology and printmaking, focusing especially on fossils, print matrices, and notions of extinction. To narrate such an integrative history, this paper traverses the 15th through 18th centuries and references the work of artists and naturalists alike. Now, because I cover 3 centuries and weave in and out of academic fields, allow me to offer a roadmap of this evening's lecture. First, I'm going to talk about the invention of lithography, then the invention of extinction, then early modern conceptions of fossils and printing, then carving, casting, and copying limestone, and finally, the extinction of print. So let's begin with lithography. Working with excavated slabs of limestone from Kehlheim and then Solnhofen, Sennefelder developed a method for printing from the surface of the stones in 1796 that he called Steindruckerei. Prior to the development of what universally has become known as lithography, the prevalent methods of printing on paper in Europe were from carved wood blocks, cast metal type, and incised copper plates. The cost of metal type for letterpress printing, as well as the expense of copper plates and the difficulties inherent to carving wood and metal matrices, motivated Sennefelder to experiment with the ubiquitous and inexpensive local limestone as a print matrix. His printing technique also alleviated much of printmaking's labor. Unlike the preparation of wood blocks and copper plates, which necessitate great technical skill, lithography requires its practitioners only to draw on the stone with a greasy material using a brush, crayon, or any other mark-making instrument. Thereafter, a printer, relying on the repulsion of water and oil, etched the designs into their surfaces with acid in preparation for printing. By the early 19th century, the ease of marking and printing the stones commenced the decline of earlier modes of printmaking. Nicolas Henri Jacob allegorically celebrates the new printmaking technique in his Genius of Lithography, produced for the first French edition of Sennefelder's lithography manual. A winged male figure holds the ink-laden brush with which he marked the stone with the names of Bavarian and French practitioners of lithography, while a female figure, having inked the stone with the roller in the foreground, pulls an impression from the matrix. Her actions align women's and the stone's generative capacities, suggesting the feminine nature of the printing matrix. The female figure effectively begets a newly born multiple of what appears on the surface of the stone. Jacob's lithograph also includes the depiction of a Münchnerin at the center of the printing press's crank wheel. The French artist who was the official painter to the Prince of Eichstätt also lauds the Bavarian source of the stone, noting its origin on the side of the stone itself. And you can see that in the lower right. The texture of the sedimentary stone was well suited to accurately capturing marks made on its surface. Sennefelder's original German 1818 lithography manual features a chapter on the benefits of the local Solnhofen limestone, touting its light color, plentitude, cheapness, and fine grain. The limestone excavated for printing sometimes also contained fossils. In relating how to choose the best stones for printing, Sennefelder described benign marks that might inhabit their surfaces. He lists, and I quote, very small deep veins which often are as fine as hairs, yellowish and grayish spots, and impressions of fossil plants and fishes. He goes on to say, and I continue the quote, "The fossils are not harmful. It is rare to find a stone as large as a sheet of notepaper that is entirely free from these little defects." The happenstance that records of plants and animals already were embedded in the stone may have suggested that further representations could be extracted from the stones through printing. The Solnhofen quarry not only served as a pictorial archive of the history of nature fixed in stone, it also proffered an operational model for creating further indexical images. The same year that Sennefelder invented lithography, another groundbreaking development materialized from the Bavarian quarries. In 1796, Georges Cuvier delivered a lecture at Paris's National Institute of Sciences and Arts that established extinction as a historical fact. Prior to the French zoologist's revolutionary speech, the idea that some animal and plant species are no longer extant had been proposed but doggedly discredited because it ran counter to fundamental aspects of Christian theology. Divine providence, the doctrine that God had created the universe with forethought and exercised great care to preserve its natural order, didn't allow for the disappearance of species. Instead, the fossilized flora and fauna that were found in stone were considered quirks of nature, images made by the earth itself. The Bible also discouraged notions of extinct species by offering evidence of God's maintenance plan. Noah was directed to build an ark and collect pairs of all the animals to save them from the flood God planned to cleanse the earth. Likewise, the principle of plenitude established God's creation of the universe as complete. The disappearance of species would have undermined the universe's perfection by interrupting the great chain of being, the hierarchical interconnectedness of the divine with every other heavenly and earthly creature. Although through the 17th and 18th centuries, empirical evidence overwhelmingly demonstrated that these theological notions were unfounded and that the Earth's geological history differed from biblical history and chronology, doctrinal conceptions of the universe prevailed until Cuvier's research verified the fact of extinction. Cuvier came to the idea of extinction through encounters with the paleontological record, petrified animal specimens encased in rock. During the late 18th century, Cuvier procured for study numerous specimens from the gypsum excavations around Paris and the limestone quarries of Solnhofen. The Bavarian quarries were formed about 150 million years ago at the end of the Jurassic period, when saltwater lagoons with muddy carbonate bottoms covered what is now Bavaria. The silty, salty water trapped local flora and fauna, and when the lagoons dried up, the fine-grained sediment hardened into slab limestone, which you of course call Plattenkalk, preserving with great precision the fossilized forms of over 500 different species of plants and animals. Fossils are the indexical vestiges of previously living organisms formed when minerals from groundwater and sediment replace organic matter as animal and plant tissue decays. They are not remnants of the original organisms themselves, but stony recreations of them. As such, fossilization is a form of casting. Using the evidence of such fossils, including those from Solnhofen, Cuvier theorized a history of the Earth that described the prehistoric lives and disappearance of species. Just as the fine-grained sediment that comprises Bavarian limestone was well suited to capturing marks made on its surface for printing, The sedimentary deposits at the bottom of the Jurassic era sea made it an ideal environment for the preservation of fossilized organic matter. In 1784, an Italian naturalist sent the fossil skeleton of an unknown species found in Solnhofen limestone to Cuvier, who named it pterodactyl, a previously unidentified flying reptile. The study of such specimens from the Bavarian limestone made his declarations about extinction possible. A lithographic representation of the limestone block in which the pterodactyl was embedded serves as the frontispiece to the 1818 English edition of Cuvier's essay on the theory of Earth. The draftsman shows the fractured edges and texture of the limestone, emphasizing the material nature of the discovery. A comparison with the original fossil demonstrates how faithfully the lithograph captured the form of the winged creature, both as a fossil and as an image generated from a slab of limestone. Extinction as an idea was conceptualized through the fossil record in stone, coincidentally finding its most convincing visualization as an image printed from a matrix composed of the same limestone. Giving pictorial form to a previously unknown species enabled their identification as lost organisms. And significant to the intertwined histories of paleontology and print, lithographic images also etched that knowledge into stone, emulating the manner that fossils were cast chemically in the same material. And now, just to be clear, I'm not saying that the fossil itself was used as a printing matrix, although I bet at some point they were, but the limestone printing matrix, similar to the fossil, holds knowledge of the extinct creature. Okay, let's talk about early modern conceptions of fossils and printing. Over 2 centuries before Cuvier's statement on extinction and the invention of lithography, the first volume on fossils to reveal material and conceptual links between fossils and printing was published. The Zurich natural historian Conrad Gesner's 1565 De Rerum Fossilium includes a comprehensive set of woodcut depictions of fossilized objects. Although printed from wood blocks rather than lithographic stones, the volume's illustrations suggest a relationship between the print matrices and the fossils they depict. Such woodcuts were part of the trend of visually cataloging objects from nature in the 16th century. In the preceding decades, Andreas Vesalius's anatomical treatise, Leonard Fuchs' botanical compendium, and Gesner's own zoological anthology set the stage for the publication of his book on fossils. Gesner, like his predecessors, employed draftsmen to make drawings and specimens and woodblock cutters to carve the designs. While scholarly focus is usually on the consequent woodcuts, it is the wood blocks that suggest an affiliation to fossils. In his treatise, Gesner refers to his own collection of fossil specimens, which served as the models for the drawings and their related print matrices. Although none of Gesner's wood blocks have survived, it seems he intuited and exploited the physical and conceptual relationship between the fossil specimens and the woodblocks made in imitation of them for the replication of images. Like the ancients before him, Gesner defined fossils as stony objects dug up from the earth, including those of both organic and inorganic origin. He did not identify fossils as the remains of once living creatures, but following Neoplatonic thought, considered them objects produced by natural forces within the earth itself. Gesner states, "Indeed, the images and shapes engraved upon these things in nature," and by this he means fossils, "reveal something of their grandeur. especially those that have not come about fortuitously, but are distinctly natural, and if I may say so, specific, and appear always to be cleaving to some genus as if particular to it, such as the genus of plants. Fossils' resemblance to objects and creatures that inhabit the universe was explained by the idea of affinity. They looked like known things because they had a cosmic correspondence to them, not because they were impressions or casts of previously extant beings. The chapter titles of Gesner's book reflect this taxonomy, with such headings as stones that resemble some heavenly bodies, stones that resemble plants or herbs, and stones that resemble aquatic animals. Described in terms of likeness to other objects, rather than as having an indexical relationship to an original creature, fossils are understood as images and therefore called throughout his text imagenes, icones, and figurae, images, pictures, and shapes. Within this paradigm, a fish fossil, discovered within the shale deposits of Saxony, was considered a naturally occurring representation of a fish, not the vestige of a creature that once inhabited a prehistoric German sea. As such, Gesner's woodcut illustration is an image of another image. Thus, the gesture of carving an image of the fish into the woodblock for printing was an alternative mode of implanting a picture into another sturdy substrate. Gesner, or his block cutter, was following the Earth's model of making highly textured relief images in a plank of hard wood. A comparison of a fossilized fish and one of Gesner's woodcut illustrations is instructive. The raised relief lines that comprise the fossil skeleton are akin to the raised relief lines of the woodblock employed to produce Gesner's illustration. Rather than delineate the Saxon fish fossil's skeletal structure, Gesner's woodcutter instead chose to portray its scaly surface and the rough texture of the shale. To do so, he would have had to cut raised contour and crosshatch lines into the woodblock surface, consequently inking the highly textured relief for printing. Although printing from the surface of stone would not be developed for almost 250 years, the limestone in which such fossils were engraved, and here I'm using Gesner's language, perhaps suggested the possibility of printing to those naturalists already acquainted with relief reproductive technologies. Ulysses Aldrovandi, like his predecessor Gesner, also theorized that fossils imitated forms from the natural world, but were inorganic themselves. The Italian naturalist who coined the term geology authored the Museum Metallicum, which was published in 1648, 43 years after his death. Its text and many woodcuts delineate different types of fossils. For instance, trace fossils consist of imprints created by living organisms, like the snake trails depicted in the central image, which Aldrovandi considered natural curiosities formed by the earth in imitation of the movement of animals. Body fossils, however, he describes as the consequence of fluids circulating within rocks that create images in imitation of species from the organic world. That no animal tissue or bones were present in the stones confirmed for the 16th century naturalist that they were not of organic origin. While most early modern naturalists considered fossils reproductive images, and by that I mean images that replicate objects from nature, they did not conceive of them as reproductive in the sense that they were indexical casts of previously living plants and animals. An intact group of Aldrovandi's woodcuts are carefully preserved in Bologna, along with some of the original fossil specimens and the drawings of them. Notably, Aldrovandis cut wood blocks depicting fossils, when impregnated with ink, resemble actual hard, stony fossils set in hardened sediment. The resemblance of the actual fossils to their representative matrices must have been recognized during their production and consequent printing. One watercolor of a fish fossil commissioned by Aldrovandi looks more like a cut wood block than a fossil captured in stone, prefiguring its translation to a wood print matrix. In contrast, the drawing's inscription, which reads, "A stone containing the shape of a fish and drawn according to nature," refers to the stony nature of the specimen while emphasizing nature's agency in the production of the image. While the nascent field of paleontology informed early modern printmaking and other forms of artistic practice also influenced early paleontological writing. As Robert Felfa has comprehensively documented, early modern naturalists describe nature as having artistic agency and even as using techniques aligned with contemporaneous artistic processes. When discussing fossils in fine-grained sedimentary stone, Felfa notes that Aldrovandi relies on the language of drawing, painting, sculpture, and especially printmaking to explain their appearance. Similarly, in describing the woodcut depiction of the same fossilized fish printed in his Museum Metallicum, Aldrovandi further affirms the artistic agency of the stone and states that, quote, "Playful nature had printed the fossil precisely in stone," end quote. What nature drew and incised in stone, Aldrovandi drew and carved into wood for printing, associating the production of two types of fossil images. To further the analogy between fossils and print matrices, I'm showing you a halved slab of Solnhofen limestone incorporating a body fossil of a fish. Splitting the stones that encompass mineralized body fossils creates two counterparts: a relief cast of the specimen and a corresponding impression of it. The forms produced by this split are structurally analogous to relief and intaglio printing matrices, the former creating woodcuts from their surfaces and the latter creating engravings from the incised lines below the surface of the copper plates. Viewing an actual fossil alongside Aldrovandi's woodblock carved in imitation of a halved body fossil and a printed impression from the inked block makes apparent the visual and theoretical correspondences between the images engraved by nature and those incised by a human hand. The surface of the woodblock from which Aldrovandi's illustrations of fossils were printed were cut to exaggerate the appearance of wood grain, suggesting conceptual and structural correspondences between the original fossilized specimens and the print matrices on which they were carved. It also suggests material interchangeability between the two hard substrates. Aldrovandi's block cutters imitated stone models, translating their forms to wood blocks and thereby replicating their appearance and structure in another durable substrate. So more on the stones. A few decades prior to the earliest illustrated publications on fossils, and centuries before Senefelder determined the printing capacity of Solnhofen limestone, early 16th century Bavarian sculptors recognized the stone's reproductive potential and embedded their own images in it. They may have been inspired by the use of the limestone in the 13th century for the decoration of crusader gear. The scaly exterior and spiny fins of 2 mullet were carved into a limestone template, now at the Metropolitan Museum of Art, for embossing designs onto leather shoulder shields. The incised fish mimic the impressed body fossils of marine specimens found at Solnhofen, which may have served as visual models for the decorative matrices. Hans Daucher, an Augsburg stonecutter who produced small bas-relief sculptures and portrait medals, is the best known of the Bavarian artists who utilized Solnhofen limestone for sculpture at the start of the 16th century. Using the local material was a logical choice for him. Solnhofen's quarries are located about 80 kilometers from Augsburg. For centuries, the slabs with their fossils had been excavated from quarries in Eichstätt and Solnhofen for use as roof and floor tiles. As Thomas Esser writes in his monographic study of Daucher, around 1500, the region's sculptors turned from sandstone and marble to the native limestone because the dense but pliant slabs were suited to precision carving. Notably, artists like Daucher also recognized that the stone was durable enough for casting. The relief sculptures and portrait medals made from the Solnhofen limestone often were used to generate further objects through sand casting. For instance, Daucher's 1522 portrait of Charles V on horseback generated the adjacent bronze plaque, and his 1526 portrait in limestone of Ludwig II was the template for a bronze medal. Sand casting was accomplished in the 16th century by impressing a carved limestone relief in packed sand contained within a flask. When the limestone model is removed and the 2 halves of the flask sealed together, a molten copper alloy is poured in to fill the empty space left by the limestone form. The casting process mimics fossilization, which also depends on creating an impression and filling negative space. In using the fossil-laden Solnhofen limestone as a matrix for generating further objects, Daucher was following the example of nature in making images from the stone, just as his predecessors had nearly 300 years earlier in their decoration of leather combat attire. Carving the limestone with its inevitable fossilized specimens compelled Daucher's confrontation with nature's own image-making capacities. In cutting the limestone reliefs, he had to navigate forms and images embedded in the stone, allegedly made by the earth itself. While the stone slabs are cut in such a way that fossil specimens are not visible on the panel's carved surface, Daucher's 1527 relief of the meeting of Emperor Charles V and his brother Ferdinand II, now at the Morgan Library, shows evidence of fossil inclusions at the bottom edge of the slab, where a leaf crustacean and crinoid, which is a marine invertebrate, are visible. These inclusions may have influenced some of the forms carved by Daucher into the depicted scene. Ferdinand's feathery plume seemed to imitate the feathery fossilized forms visible at the edges of the stone. Similarly, embedded crinoids seem to be the inspiration for the plants in the foreground of Daucher's most famous panel, Albrecht Dürer wrestling Apelles to the ground, a battle between the most renowned painter of antiquity and Daucher's celebrated contemporary. Perhaps my claim about a visual correspondence between the depicted plants and the crinoid is a case of false morphology. But affinity, a correspondence between fossils and objects that exist in the world, was one of the means early modernists like Gesner and Aldrovandi used to understand fossils. The many crinoids in the Solnhofen limestone, with their wavy arms mimicking wafting weeds, may have prompted Daucher to emulate the stone's image-making capability and replicate the weedy matter. And you will have noticed by now that most of my images of fossils come from Harvard's Museum of Comparative Zoology. But I had an opportunity yesterday to go over to the Paleontology Museum. So the crinoid on the bottom left is actually here in the museum in Munich. While Daucher scholar Thomas Esser claims that Apelles' old-fashioned armor with its bat-like shoulder decoration identifies Apelles as belonging to a bygone era, a creature of the ancient past, the armor decoration also resembles a fossilized trilobite, another of the fossils common to Solnhofen. In fact, the shoulder shields are of the type impressed with designs cut into Solnhofen limestone during the Middle Ages described above. These details suggest that Daucher was aware of both the fossils implanted in the limestone and the stone's historic uses for the replication of forms and designs in armor decoration. Conspicuously, other of Daucher's limestone sculptures include depictions of plants and animals that resemble petrified Solnhofen specimens. Two limestone reliefs attributed to Daucher, the bearded man and the woman with skull, position the figures against inscribed, textured floral backgrounds, which seem to nod to the stone's inherent fossilscapes of petrified leaves, branches, and other floral specimens. By signaling the stone's innate image-making capacity, the artist alludes to both a typical portrait backdrop of European brocade, as well as the natural appearance of Solnhofen limestone. In the second half of the 16th century, the Roman naturalist Michel Mercati wrote of fossil-laden stone, and I quote, "Its material is hard and lustrous, covered entirely with leafy texture, with interspersed flowers as beautiful as a Belgian carpet or damask silk." Daucher, in placing his figures against such a backdrop, visually predicts Mercati's comparison of decorative European textiles and the sedimentary stone inscribed with floral fossils. Daucher's 16th century contemporaries also appreciated that the limestone embodied its own precisely depicted images. Although the source of the fossilized specimens was debated, souvenirs from Solnhofen quarries were preserved, collected, and displayed. According to a letter documented by Thomas Esser, Frederick the Wise of Saxony was gifted a fossilized fish in 1523, now lost, described as a stone inside which is a grown fish. This is a truly strange thing which nature has thus created. A similar fossilized fish embedded in stone remains among Archduke Ferdinand II's possessions at Schloss Ambras, his Innsbruck castle. Dated 1534, the inscription that accompanies the fossil references the Diluvian flood, which was believed to have reshaped the Earth's surface and scattered its flora and fauna, resulting in marine life found generations later in anomalous environments. In another instance, the German collector of curiosities, Philipp Hainhofer, offered an explanation of stones with fossils that rhymes with Gessner's account of their existence. In a 1611 description of the local stones that the bishop of nearby Eichstätt was using to renovate his castle, Hainhofer claimed the stone showed fish, leaves, birds, flowers, and many strange things which nature lets us see in them. Much to the wonder of these early modern noblemen and collectors, nature was actively creating images of flora and fauna in the local stone. the same stone studied by naturalists like Gesner and used by artists like Daucher. Daucher's reliefs also may allude to contemporary understandings and perceptions of the limestone and its fossils. The foreground of Allegory of Virtues and Vices shows humans, animals, and trees being carried away by a torrent of water. Now, while this is certainly not the deluge of the Bible, it was believed during Daucher's lifetime that the presence of marine fossils found in places like landlocked Bavaria were the result of them being carried there by the flood sent by God to cleanse the earth, as noted by Hainhofer above. The artist's relief of Emperor Maximilian on horseback as St. George also suggests a contemporary understanding of Solnhofen's fossil record. The trampled dragon under the feet of the horse, with its webbed claws and bony neck and ribs, resembles the petrified skeletal structure of creatures emerging from the stone. Unidentified monsters were a feature of the Bavarian stone, like the pterodactyl that were common to the region. Adrienne Mayer, in her book, The First Fossil Hunters, argues that the multitude of fossilized remains in the Mediterranean basin were known to the ancients and were integrated into their mythological imagination. Daucher's sculptures made from the Jurassic stone also self-consciously reference the material of their making and the stony Solnhofen terrain. For instance, Daucher's Christ carrying the cross is based on one of Albrecht Dürer's woodcuts from the Nuremberg artist's 1511 Large Passion series, showing Christ on his knees, having stumbled under the weight of the cross. In the woodcut at left, Christ leans his left hand on what seems to be the stump of a tree, true to the woodlands Dürer knew around Nuremberg, as well as the material of the block from which the woodcut was printed. In the Augsburg sculptor's relief, however, Christ's hand rests on a squared slab, presumably made of the local limestone, which was often used as floor tile. The stone is also shown in its natural slab form, crumbling under Christ's knee, signaling Daucher's choice of the native stone over other possible materials. The artist also intuited that the Solnhofen limestone, with its already existing embedded images, was an apt substrate for the reproduction of other previously existing images. Daucher's use of Dürer's woodcuts as models for his stone panels initiated the relationship between Solnhofen limestone and printmaking on paper at the beginning of the 16th century. That Daucher based some of his limestone reliefs on woodcuts anticipates the stone's receptivity to printed images, as well as its use as a printing matrix. According to Esser, cutting the limestone deployed tools similar to those used to carve woodblocks, further affirming a fundamental material and conceptual relationship between the Solnhofen limestone and wood print matrices. Daucher's 1518 limestone Annunciation is based on another of Dürer's woodcuts, the Annunciation from his Life of the Virgin series. Choosing to copy his woodcuts can be construed as an alternate demonstration of the Neoplatonic idea of affinity. Daucher deployed Dürer's printed images as models because the stone was receptive to already existing images, especially those produced from wooden print matrices, perhaps modeled on relief body fossils. This again suggests a material interchangeability between the carved stones and woodblocks. So let's return to the idea of lithography and extinction. When at the start of the 16th century, Daucher and contemporary Augsburg sculptors shifted to Solnhofen limestone, then employed their relief sculptors to cast metal plaques and portrait medals using a method that imitates fossilization, the stone's generative capacity was established. A few decades later, fossils within limestone provided conceptual and operational models to early naturalists in the carving of wood blocks for illustrations within their printed treatises on fossils, laying the groundwork for the stone's future printing possibilities. That conceptual connection also is evident when these naturalists describe how the stone's embedded fossils were the result of nature's painting, sculpting, and engraving skills. That artists like Daucher copied the designs of contemporaneous woodcuts further affirmed the stone's relationship to printmaking. The sense of Solnhofen limestone as a reproductive matrix prevailed into the late 18th century when Senefelder determined how to exploit the stone's generative potential even further. Instead of using it to cast a limited number of portrait medals or metal plaques, or engaging in laborious carving of wood blocks in imitation of stone models, Senefelder developed the means to generate multiple printed indexical impressions on paper from the surface of the stone itself. So how did Senefelder, after 300 years of developments in paleontology and printmaking, come to the idea that printing from Solnhofen limestone's flat surface was possible? The limestone and its history provided the answer. As Senefelder claimed in his treatise on lithography, and I'm going to repeat the quote, impressions of fossil plants and fishes found in the stone are not harmful. It is rare to find a stone as large as a sheet of notepaper that is entirely free from them. These same indexical images had been recorded in and extracted from the stone for centuries. The slabs of stone with their embedded fossils suggested the stone's inherent reproductive capacity to early naturalists who commissioned woodblock matrix counterparts for printing. But the stones also prompt other questions, many unanswerable or unresolved, such as, did Daucher's sculpted limestone slabs with their 16th century reliefs suggest the idea of using them as printing blocks to Senefelder? Did he imagine inking the sculpted limestone surfaces in the same manner that the sculpted surfaces of wood blocks were inked and printed? While Senefelder may have envisioned what was necessary to mark and print the fossil-ridden stones, the stones themselves suggested their own agency, or in the words of literary scholar Tiffany Jo Worth, their own lithic imagination. The paleontological record of the Solnhofen limestone not only contributed to understanding the stone and the nature of reproducibility, it also inspired centuries of experiments in reproductive image making from the stone. Let's return to the idea of print matrices as fossils. Extinction has been an inherent vice of printmaking since its inception because the medium's matrix usually is cast off, considered superfluous to the finished print. As such, it is related to the disappearance of the organism's body in the formation of the body fossil. Both mark the extinction of the authentic original. By their very nature, they are related. Fossils are a pictorial record of the history of nature, while inscribed wood blocks, copper plates, and lithographic stones are an archive of the history of the pictorial arts. as we look for new paradigms to interpret early modern art in relationship to environmental history, can we imagine the histories of printing and paleontology to be intertwined and coextensive? When, in 1796, Cuvier established that fossils were the vestigial remains of previously living organisms, and Sennefelder invented a means of printing from fossil-laden prehistoric stones, another extinction took place. That of the idea that the Earth itself was producing images. The refutation of Neoplatonic thinking, however, did not halt the concept of generating images in and from lithographic limestone. Instead, the development of lithography marks a moment in a historical continuum of indexical images emerging from durable substrates. Fossils offered naturalists and printmakers alike a tangible model and operational paradigm for the production of knowledge through material means. Both fossils and print matrices embed knowledge in a solid ground and archive it, seemingly forever. In the 21st century, we're facing the extinction of printmaking as a physical process, one in which the production of knowledge is materially realized through inscribing it into matrices. The paleontology of prints compels us to consider what else is lost when the physical artifact and incised evidence of knowledge production disappears. Finally, perhaps it's possible to imagine printmaking as a geological period, one that lasted from the 15th century through the present. Doing so enables tracing its evolution through a stratigraphic analysis of its matrices, noting a progression from rough to smooth, from the deeply carved wood blocks of the 15th century through the more delicately incised copper plates of the 16th and 17th centuries to the semi-smooth surfaces of lithographic stones in the late 18th century. Modern printmaking practices have proceeded to even slicker surfaces, such as aluminum and acrylic. And contemporary printmaking moves beyond any substrate at all to the digital and the immaterial. That sounds like extinction, doesn't it? Thank you.